Hi and welcome to Chem in 3. Today we're going to talk about electronegativity, electron affinity, ionization energy, and ionic radii. Electronegativity of an element is a measure of its ability of the atoms to retract a bonding pair of electrons. The Pauling scale is the most commonly used, which helps us understand which degree of electronegativity an element has. The scale ranges in between 0.7 and 4.0. Fluorine, which is the most electronegative element, has a value of 4.0, and the value ranges down to cesium and francium, which are the least electronegative, at 0.7. Basically, in other words, what electronegativity means is how well the nucleus of an atom can pull other electrons towards itself. Some atoms are better at doing this than others. Atoms with more protons in the nucleus most commonly have higher electronegativities, because the positive nuclear charge is higher and therefore it can pull more electrons towards itself. However, atoms with more electron shells have lower electronegativities because there is more shielding from the positive nucleus, and so the atom will not be able to pull electrons towards itself as easily. The trend of electronegativity in the periodic table is that in general it increases across the period and decreases down a group. Knowing the electronegativity of an element can be useful when predicting what type of bond two atoms will form. Examples of this are: no electronegativity difference between two atoms leads to a pure non-polar covalent bond. A small electronegative difference leads to a polar covalent bond. And a large electronegativity difference leads to an ionic bond. Electron affinity. The electron affinity of an atom or molecule is defined as the amount of energy released or spent when an electron is added to a neutral atom or molecule in the gaseous state to form a negative ion. A higher electron affinity indicates that an atom more easily accepts electrons and vice versa. The things that affect electron affinity the most are atomic radius and nuclear charge. The smaller atomic radius, the closer the outermost shell is. Therefore, it is a stronger attraction between the nucleus and the incoming electron. That means the electron affinity is higher for smaller atoms. Nuclear charge also affects electron affinity. The nuclear charge can be defined as the positive charge from the protons in the nucleus. The more protons there are, the greater the attraction is to the electron. Imagine you're carrying a bag and adding things to it. Naturally, the bags become heavier, and there is a change in the energy you expend when the weight changes. In the same way, when an atom gains electrons, an energy change occurs. This energy change is what we call electron affinity. When looking at the periodic table, the atomic radius increases from top to bottom. Moving down a column, therefore, the electron affinity increases from the bottom to the top of the column. From left to right, the nuclear charge increases, resulting in a greater attraction to incoming electrons. So, we can say that from left to right across a period, the electron affinity increases. Ionization energy is the minimum amount of energy required to remove 1 mole of electrons from 1 mole of gaseous ion. This means in practice is how much energy is needed to pull away an electron from the atom, creating an ion. For example, the first ionization energy, i.e. how much energy is needed to pull away the first electron from the atom of lithium, is 520 kilojoules. What determines the ionization energy is what we call effective nuclear charge, which is the sum of the pull of the nucleus on the electrons and the electron shielding, the repellation of valence electrons from electrons closer to the nucleus. This leads us in on ionic radii. Neither ions nor atoms have a hard boundary. However, for the purpose of identifying trends and differences in size between ions, we imagine that they do. An atom which has lost 1 or more electrons is called a cation. The cation will have a smaller radius since the shielding is smaller and the nucleus now has a greater pull on the electrons. The opposite happens in the anion, where electrons are added. This means that the shielding gets greater and the nucleus has a weaker pull on the valence electrons, making the radius greater. So, let's test if you have listened. Pause the video here and read the question and test yourself. The answer to the question is that the electron affinity will increase. Thanks for watching.